Assalamualaikum warahmatullahi wabarakatuh. So first, I will explain the introduction of logical implications. So the statement, if P then Q, is also can be written as P implies Q. The symbol arrow means implies. So P implies Q can be written as P arrow to Q. These logical implications is to designate the statement which is the implications of Q by P. It is also to prove the logical implications of two statements either by using a truth table or rule of inference. The notation for logical implication is this symbol.
So now I will explain to you what is logical implication by truth table. So actually, logical implication by truth table is a technique to prove by using a truth table where if the implication of a statement is a tautology, then this statement is logical implication. So now I will explain how to do example 2. So here is the question for example 2. So here we have to use the truth table to determine whether this statement, which is not P implies Q and P implies R and R implies S, is logically implies to Q or S. So here I simplified it, or I use to label it as not P implies Q is A, P implies R is B, R implies S is C, and Q or S is D. So here, as you can see, it is a very long word and it has 16 rows in this truth table because in this statement we have 4 variables which is P, Q, R, and S. So we have to start with the first column is 8081, 4041, 2021 and 1011 for the column P, Q, R, and S. Moving on to the negation P, we negate the P, so we just negate the P here. So this is the answer. And then for not P implies Q, we know that if not P is true, Q is false, then it will be false. So this is the answer. We have to see the not P column and with the Q column, so we will get the answer here. And then for P implies R, it's the same. If P is true, R is false, then it is false. So here is the answer. So we have to look at the column P and column R to get this answer. Next we have R implies S, which is if R is true, S is false, then it will be false. So here is the answer. We have to look at the column R and S here to get this. Next is A and B. So here A and B is not P implies Q and P implies R. So we have to see the column, this one is column A. Okay. Okay, and this one B, this one C. So for A and B, we have to look at A column and B column. So how to get it is, if A is true and B is true, we will get true. Okay, and the rest will be false. So here is the answer. And we're moving on to A and B and C, which is this one. Okay, not P implies Q and P implies R and R implies S. So here we have to look at this column. Okay, this column is A and B, right? A and B. So we have to look at this column and this column. Okay, so it's the same. Or actually, this one is like this. So if A and B is 1, C is 1, and we got the answer is 1, the rest is false. So here is the answer. And then next column is Q or S, which is D. So or is when Q is false, S is false, then we will get false. The rest is true. So have the column Q, and we have the column S. So we look at these two columns, and we will get this answer. And finally, is we will determine whether this statement, whether A and B and C is logically implies to D here. So this column with this column. Okay. So here, how to get it here is A and B and C. If A and B and C is true, D is false, then it is false. The rest is true. So as you can see here, there is no false statement, false B here, because you can see here it is 0, 0, 1, 1, 1, 1, 1. So what is this mean? Okay, this means that we get okay, now, so how we conclude this is, since the last column we get tautology, therefore not P implies Q and P implies R and R implies S is logically implies to Q or S. So this statement is logically implication.
What are rules of inference? Mathematical logic is often used for logical proof. Proof are valid arguments that determine the true value of mathematical statement. An argument is a sequence of a statement. The last statement is the conclusion, and its preceding statement are called premise, or we can call that as hypothesis. The symbol of three dots, or we can read as therefore, is placed before the conclusion. A valid argument is one where the conclusion follows from the true value of the premise. Rules of inference provide the template or guideline for constructing valid argument from the statement that we already have. So this is for the example 2. The statement is, if Zahid does not go to training in the morning, then Ali will play handball in the afternoon. If Ali plays handball in the afternoon, then Bulat will go shopping in the evening. Zahid does not go to training in the morning. If Bulat goes shopping in the evening, then he will book bus ticket in the morning. So, the first question asks, write all the four primary statements using the variable P, Q, R, and T. So, the first statement is P. So, Zahid does not go to training in the morning is a P statement. But we know that statement cannot be a negative statement. So, not, we remove not, and the P statement will be Zahid go to training in the morning. And the second statement is Q, which is Ali will play handball in the afternoon. So this is the Q statement. The third statement is R. The statement is Bulat will go shopping in the evening. So this is the R statement. And the last one is T. And the statement is he will book bus ticket in the morning. So this is the T statement. So the second question asks, write the argument using the variable in mind. So first, the first argument is not P implies Q. And the second argument is Q implies R. The third argument is not P. And the last argument is R implies T. So this is the argument. The third question is, find the logical conclusion of the argument by using the rules of inference. So first, we can do this as premise. So this is premise 1, premise 2, premise 3, and premise 4. So we label it with 1, 2, 3, and 4. So first, you can look at 1 and 3 argument. You can get Q as your 5th argument. So using the modus ponens, you get Q. So the result was 1, 3 using modus ponens rules. So the 6, you can look at 2 and 4. You can cut R and you get Q implies T. You can use rules of syllogism. So 2, 4 using syllogism, and you got Q implies T. And the last is you look at 5th and 6th argument. Using the modus ponens, you will get T. So the conclusion is T, and you can write it as Bulat will book bus ticket in the morning.
For choose value of logical implications, the statement will be false if the hypothesis is true and the conclusion is false. Otherwise, the statement will be true. So here I will explain the example for the true value of P, Q, R, and X. So for the implications, we know that 1 in plus 0, we got 0. So this statement is invalid. Statement given is invalid. So we know that the value of R is 0. Therefore, to find the value for P, Q, R, and S, we can search it by the N symbol first, because this part, both of it need to be 1. So for N, if both this one is going to be 1, therefore P or not Q must equal to 1. Since it's N, P and not Q, so we know that P is 1 and not Q is 1. Therefore we get P and not Q is 1. So Q, not Q is a negation of Q, so we get here Q is 0. P implies with S, either both of these need to be true or one of it is 0. So we can say that P implies S is true. Therefore, since P is 1, then S is 1. So the true value of P is 1, Q is 0, R is 0, and S is 1. Now let's move to the second method. Now I will explain the second method. The second method is the easiest one because we did not have to draw any tables. So since we know that the statement is invalid, therefore R equals to 0. And then P implies S or P implies R, and P and not Q are equals to 1. So we can say that P and not Q are equals to 1. So since P and not Q are equals to 1, therefore we will get the true value of P are equals to 1 and not Q are equals to 1. Since we are not looking for not Q, we are looking for Q, therefore Q are equals to 0 because not Q are the negations of Q. And then P implies S or P implies R are equals to 1. Since P are equals to 1 and R are equals to 0, therefore P implies R are equals to 0. So since the statement is in OR, either one of them is 1, therefore the statement will be true. So P implies S are equals to 1. P are equals to 1, therefore S are equals to 1. So we will get the true value of P are equals to 1, Q equals to 0, R equals to 0, and S equals to 1.
In conclusion, in all three subtopics of logical implications, which are logical implications by truth table, by rules of inference, and by primitive statements, we can conclude that we can determine the logical implication of a statement in three distinct ways based on the specific question posed. That's all from us. Thank you.